condition for maximum power transmission in the belt drives. So here consider the belt drive. This is a driven pulley. This rotates in this direction. This is the tight side of the belt and this is the slack side of the belt. T1 is the tension in the tight side of the belt. T2 is the tension in the slack side of the belt. So the belt cross section, let us assume the belt is of rectangular cross section. It is of rectangular cross section. This is the cross section of the belt. B is the width of the belt. T is the thickness of the belt. The pulley rotates in this direction. Right? This is the tight side. This is the slack side. Let sigma equal to maximum safe stress in the belt, because the belt is subjected to stress, right? Tensile stress. It is subjected to tensile stress. Let sigma equal to maximum safe stress in the belt. B equal to width of the belt. T equal to thickness of the belt. Capital T is equal to maximum tension in the belt. T is the maximum tension in the belt. We will see what is maximum tension. T1 equal to tension in the tight side of the belt. T2 is the tension in the slack side of the belt. Already we have derived Tc is equal to centrifugal tension in the belt. M is equal to mass per unit length of the belt. So we know that centrifugal tension Tc is equal to mv square, where v is the linear velocity of the belt. We are going to find the condition for maximum power transmission in the belt. Into cross-sectional area, cross-section area. Cross-section area of the belt is width of the belt into thickness, B into T. Therefore, T is equal to sigma into B into T. So this is the maximum tension in the belt. But we have to derive the condition for maximum tension. Neglecting centrifugal tension, when we neglect centrifugal tension, T is equal to T1. Maximum tension becomes the tension in the tight side. This is neglecting centrifugal tension. Considering centrifugal tension, T is equal to T1 plus Tc. That is, when we consider centrifugal tension, maximum tension in the belt T is equal to T1 plus Tc, where T1 is the tension in the tight side, Tc is the centrifugal tension. P equal power transmitted P is equal to T1 minus T2 into V. So this is the power transmitted by the belt P. P is equal to, we know that power transmitted equal to P, power transmitted P is equal to T1 minus T2 into V. So here, substitute here, this is T1 is equal to T minus Tc, right? T1 is equal to T minus Tc, right? So this is, we are going to substitute this. We know that power transmitted T1 by T2 is equal, we know that ratio of the driving tension T1 by T2 equal to e power mu theta. So from this, T2 is equal to T1 divided by e power mu theta. You call this as equation 1. You call this as equation 2. Substitute 2 in 1. T1 minus T2 into V is the power transmitted, but T2 is equal to T1 divided by e power mu theta from ratio of driving tensions. Substituting 2 in 1, we get P is equal to T1 minus T1 divided by e power mu theta into V. Instead of T2, I substituted T1 by e power mu theta. So P is equal to T1 into 1 minus 1 by e power mu theta into V. So this is a constant, therefore P is equal to T1 V into constant. Right, so substitute here T1 is equal to T minus Tc, substitute here, therefore P is equal to T minus Tc into V into C. Right, substitute, this is constant equal to 1 minus 1 by e power mu theta. So power transmitted P is equal to T minus Tc. Right, instead of T1 I substituted T minus Tc into V into C. Right, so for maximum power transmission, so multiplying this, so P is equal to TV minus Tc into V into C. Right? So P is equal to V. P is equal to so for maximum power transmission, dP by dV is equal to 0. Right, this is the condition for maximum power transmission. Therefore dP by dC is equal to 0. Therefore it becomes T I substitute P is equal to TV minus Tc is mv square into V into C. Therefore dP by dV, I substituted Tc is equal to mv square, therefore it becomes TV minus mv cube equal to 0, right? Therefore P is equal to this TV minus mv cube, right? mv cube into C equal to 0. dP by dV equal to 0. So if you differentiate this, it becomes T minus 3mv square equal to 0. Right? Differentiate this, it becomes, right, dP by dV equal to 0. Differentiate this, dP by dV, it becomes with respect to V. So T minus 3m V square equal to 0. Therefore T equal to 3m V square. Therefore T is equal to mv square is the centrifugal tension, 3 Tc. Therefore, maximum tension T is equal to 3 times of centrifugal tension. This is the condition for maximum power transmission. For maximum power transmission, dP by dV equal to 0. Therefore, right, this is P. P equal to TV minus mvq into C equal to 0. dP by dV equal to 0. So it becomes T minus 3 mv square equal to 0. T equal to 3 T square. Right? So T is equal to 3 into mv square. Therefore, V is equal to T by 3m. Square root of 3m. So this is the velocity for maximum power transmission. Right? Maximum power transmission, maximum tension is equal to 3 mv square. That is, maximum tension is equal to 3 times of centrifugal tension. Right? Maximum power transmission, for condition for maximum power transmission is maximum tension is equal to 3 times of centrifugal tension. Velocity is equal to square root of T by 3m.